Great. Hi, everyone. It's great to see you all joining from all over the world. Welcome to the Extreme Tech Challenge category final for the Enabling Tech category. My name is Victoria Slivkov, and I'm your host today. Just to get a sense of where everybody's joining from, why don't we tap in chat and let us know what city or country you're joining the event from. Shale, do you want to take a quick look?
Hi,
Oh, here.
yep, sorry. We've got Vancouver, Boston, California, Israel, Australia, Canberra, Australia, India, Taipei, middle of nowhere, south of San Jose, California.
Great, this is fun. Thanks. I think this really reflects to the true nature of XTC that we are global. So let's first some background on Extreme Tech Challenge for those who are new to us. We're the world's largest tech innovation ecosystem for making the world a radically better place. XTC is a launch pad for the disruptive innovations that can power a more sustainable, equitable, healthy, and prosperous world. So think of XCC, we're at that nexus of this global community of innovators, entrepreneurs, big companies, VCs, academia, philanthropists, policymakers, and just general change makers that want to work together to solve the grand challenges of our time. The UN Sustainable Development Goals serve as a framework for our 7 competition categories, and that's ag tech, food and water, clean tech and energy, ed tech, enabling tech, fintech, health tech, and mobility and smart cities. Not only is this supporting tech for good is the right thing to do, but also investing in purpose-driven technology and startups also contributes to better business results. XTC was founded by legendary investors Young Sung and Bill Tai, 2 Silicon Valley-based investors, corporate executives, and entrepreneurs who have invested in and have built multiple billion-dollar companies that are household names today. They're passionate about our mission to empower founders, building innovations and technologies that improve the world, and also believe in the power of the community, this community, to identify potential market-leading companies that can impact the world in a big way and provide the rocket fuel to help them scale faster. So follow them on social media and check out Young's video interview series, The Next Wave, for thought leadership and practical advice for founders and investors alike. And through participating these exceptional startups, as the ones that you're hearing from today, gain global visibility, access to capital, corporate strategic partnerships, and mentorship. And most importantly, develop relationships and friendships that can carry them far into the future. Some highlights from XCC 2021. This year, over 3,700 startups applied from almost 100 countries, and 80 finalists were selected by over 300 judges across 21 regional competitions around the world
जो सोया
and,
था सोफा सेट पे
and through open applications. So these 80 exceptional companies all have emerged as the top 2% from a very competitive application pool. So I think this is such an amazing achievement. And to all the startup finalists, you are winners in your own right. So here's a look at the cohort of 2021 global finalists. And to learn more, head to our website, extremetechchallenge.org. And here's a look of the cohort for the Enabling Tech track. And I'm so excited for you to hear from these 4 exceptional startups shown here today. And now, before we get to the pitch, I'd like to welcome our judging panel. It is my distinct pleasure to welcome Eric Bertois. He's the general partner at Benamou Global Ventures. Dede Goldschmidt, vice president, managing director, and head of Samsung Catalyst Fund. Richard Irving, chairman and CEO at Fluence Corporation. And Zach Lashik, senior solution designer and member of its AI ethics committee at ARM. And Mark Cunningham, a prolific angel investor and startup mentor at Creative Destruction Lab. So now I'm going to turn it over to the judges for a few words on your particular interests in this enabling tech category. And as an investor, what kind of companies are you looking for? So let's start with Eric.
Yeah, so yes, good morning to you all. Good afternoon for some of you. We are an investor in the enterprise space, the B2B space, with a very strong focus on artificial intelligence and AI applied to the enterprise, looking also very deeply at cybersecurity and how enterprises are rebuilding their new infrastructure cloud native. We do a fair amount of cross-border investment, Israel, Europe, and India, and very excited to be there this morning and very impressed by the business plan which are presented.
Great, thank you, Eric. Dave, on to you.
Thank you. So good morning, good afternoon, and good night, everyone. I'm with the Samsung Catalyst Fund. We're a multi-stage venture capital fund of Samsung, investing in deep tech infrastructure and data-enabled platforms. As you know, Samsung is a core tech player, and we support new business creation for the organization, applying the lens of the startup world. This spans across multiple domains, including data center and cloud, artificial intelligence, quantum computing, networking, and many, many other domains, including enabling tech. Very excited and honored to be part of this panel today. And good luck to all the participants.
Great, thank you, Dede. Richard, please.
Thanks, Victoria. So it's a pleasure to be here again and greatly commend Young and Bill for really getting XTC focused around sustainability. Fluence is in the water and wastewater treatment space, doing about 100 million a year. Was originally a startup that my venture fund invested in 11 years ago. So got quite a long background in sustainability through water and ag tech. And really, I think the question or the challenge for the companies is to talk about not just why what you're doing is tech for good, but why you have the right focus to really drive substantial growth and become a very large entity. Because this notion of changing the world, I think, is something that is very much open to you, the entrepreneurs in this competition.
Great, thank you for your words. Zach, please.
Sure, thanks, Victoria. So I'm Zach from the company of ARM, which we're enabling the future of technology by being the backbone of compute and semiconductor IP. And us being an enabling company ourselves, we're looking to build these strategic partnerships with up-and-coming companies like yourselves in this enabling tech category, especially those involved in enhancing the SDGs, focusing on security, privacy, and in particular ethics. So excited to hear your pitches and to make some connections.
Great, thanks, Zach. And Mark.
Hi, good morning, or wherever you are. Good afternoon, good evening. I'm in Vancouver, Canada, longtime angel investor and active mentor in several programs, including Creative Destruction Lab. So I'm pretty focused on, the founder. I guess as an angel investor, I tend to kind of really emphasize most of my time on mission-driven founders. So I tend to kind of focus a lot on that. And then with that, a lot of my background is in big data and analytics, and so usually I like to see things that have an application of analytics in their technologies, in that combination, which I love to see. And of course, now we're moving into more of a climate and impact side of things. So I'd like to see that. And specifically in the enabling technology world, really what I love to see is focusing on what problem are you really solving. I find for enabling technologies, sometimes it's challenging. There's technologies hunting for a market, hunting for a problem to solve. So I would encourage the entrepreneurs to really think about that as they're giving their pitches. Thanks for having me.
Great, thank you. And judges, all have you been longtime supporters of Extreme Tech Challenge. So we really appreciate your partnership. Okay, with that, we're going to get to the pitches. So let me invite the first presenter to the virtual stage, Quintessence Labs. And what they're working on is innovations that will secure our world through quantum computing. Vikram, please take the stage.
Thank you very much, Victoria. I'll just get my screen share going here. Here we go. You can see the screen okay?
Yes.
Perfect. Well, good morning. My name is Vikram Sharma, CEO of Quintessence Labs, or Q Labs. Thank you for the privilege of sharing a little of our story with you. QLabs delivers strong protection for valuable data through the integration of cybersecurity software and quantum science. Since our founding, our mission has been to champion trust in our digital lives. As the boundaries between the physical and cyber worlds dissolve, trustworthy access to digital domain is becoming a fundamental human right. We're committed to impact at a global scale through alignment with the UN Sustainable Development Goals and our work with the World Economic Forum. It'll be no surprise that the scale of the challenge is significant. Estimates suggest that the cost of data breaches globally this year will be $6 trillion. The recent IBM data breach report presents more granular detail. The average cost of a data breach is almost $4 million, with the impact at large organizations escalating by a factor of 12 to 100. Developing solutions to respond to this risk, however, has been challenging. The traditional approach of walls around our IT systems is not working, amplified by the recent remote work trend. Further, quantum computing will break the technologies that underpin e-commerce today. A critical element of the solution is to encrypt all sensitive information. However, managing hundreds of millions and with the advent of IoT, billions of encryption keys is difficult. At QLabs, we address these challenges through an integrated set of advanced solutions. Our TSF securely manages hundreds of millions of encryption keys with enterprise performance. True random numbers are a fundamental building block of strong cybersecurity. Our QStream product is the world's fastest, delivering 1 billion per second, leveraging an effect called quantum tunneling. Our QOptica is the only commercial product in the world to implement continuous variable QKD technology to counter the cyber threat from quantum computers. Collectively, these foundational products enable enterprise-scale encryption, rendering data breaches irrelevant. We recognize that large enterprises have invested hundreds of millions or even billions in cybersecurity infrastructure. A fundamental value proposition of our products is integration with existing capabilities to improve ROI on those investments. The TAM of the three market subsegments QLabs is targeting is forecast at over 20 billion in 5 years, of a predicted 300 billion cybersecurity market. Our SAM estimate is 8 billion. Leveraging strong partnerships, we have a valuable customer base, which today includes over a dozen Fortune 500 companies with deployments in 10 countries. We're very excited to be now embarking on an all-important scale-up phase to serve the global community through our government and enterprise customers. To successfully deliver this, we host a very strong leadership team with complementary skills spanning deep tech, operations, supply chain, financial management, and importantly, growing companies. We've begun the search for the critical role of Chief Revenue Officer to round out the team. We're all strongly aligned and driven by a passion to deliver digital trust at global scale. Thank you.
Great. Thank you, Vikram, for your presentation. Over to you, judges.
Can I start, or?
Of course, jump in.
May I share the thanks? Thank you very much for your presentation. This is, it's a very impressive and, let's say, important domain, quantum safe encryption. Two questions to you, please. One, what would be the cost of the end device if this has to go into edge devices like IoT devices and things like that? Can that realistically be widely deployed or only be used by large enterprises? That's one question. The second question, there are several competitors to this very important segment like IDQ and some others. Are there like very significant differentiators that you have to stay ahead of competition?
Thank you, Didi, for your questions there. So first, in terms of the cost, currently our form factor for, if we're talking about the random number generation component of it, is more enterprise grade. So a card, which is the world's fastest by 2 orders of magnitude, puts out, as we said, a gigabit per second, is about $8,000 per card. In enterprise form, appliance form factor, it's of the order of about 18 to 20,000. But we do actually have, in fact, we've just received our first chips about a month ago, a reduction of form factor to chip scale. That will dramatically reduce the cost and make it consistent with the types of costings for chips you'd expect in endpoint chip devices. Equally, there's the opportunity to embed potentially IP blocks into existing other chip designs. So we're really excited about that opportunity. With regards to competitors, IDQ, I suppose, is a prominent one. There's a few proliferating. We have a somewhat different focus. IDQ is very focused around just the quantum side of it. At QLabs, we're focused on as much on the quantum side as an integration with cybersecurity software stacks. So we have very strong enterprise-grade key management, which we and many of our customers contend is the strongest in the world. So slightly different market focuses, but also the approach that we take to the quantum piece, in our case, is around continuous variables and integrated semiconductors for random number generation as opposed to purely optical means.
Thanks.
Great. May I jump in? So Vikram, thank you for your presentation. Can you give us a bit more information about the status of your customer deployments? Are these effectively pilots, or are they actually commercial deployments? And if so, kind of, what sort of scale and criticality in terms of, the application within the customer?
Absolutely. Thank you for the question. So, of course, we have a number of POCs which are in progress, but we actually have deployed systems which are being used in mission-critical environments today, 24/7 operation at scale. To give you 2 specific examples, one is with one of the world's largest banks, where our capabilities for random number generation and key management are deployed globally in all their data centers. And that is being used for 3 purposes: to persistently encrypt email, persistently encrypt Office artifacts such as Word, Excel, PowerPoint, etc. And the third is to inject true random numbers into their Linux security servers worldwide. So this is a very large deployment. Once it's spun up at full scale, it will protect 300,000 endpoints, such as mobile devices, laptops, and desktops. Another quick example is the world's largest cloud document management company for law firms. They have over 3,000 customers in over 100 countries. Again, we're in all their data centers, and our technology is being used to protect over 2 billion documents today.
Thank you.
Pleasure.
Thank you, Vikram. One question. Could you tell us how easy it is to integrate your solution in an existing environment?
Thank you very much. Great question. That's something we've really focused on really hard and built a number of integration options for our products into existing enterprise cybersecurity infrastructure. So to give you an example, like with the very large bank that I spoke of, we were able to ship from our manufacturing facility in San Jose direct to the customer. And once they were unboxed and racked in the data centers, it was typically less than half a day per data center to get the units operationalized.
Thank you.
My pleasure.
Vikram, Mark, just a question on when you're, what is your biggest source of friction when trying to sell to a customer? I notice you're looking for that CRO, and you think about a real full force go-to-market strategy. What are you seeing today as your biggest source of friction in being able to get your solution implemented or sold to and then implemented into an enterprise?
Thank you, Mark. The first is that because this is a piece of cybersecurity infrastructure that really goes into the foundational level of the cybersecurity stack, the assessment of the technology takes a period of time to understand it and look at doing a pilot program and then integrating it into your cybersecurity environment. So one of the sources of friction is simply the time and the cycles that it takes. And being a relatively newer company, you undergo probably twice as much scrutiny as you would otherwise. But as we've got more and more referenceable customers, in fact, we just made it to the approved products list for the CDM program run by Department of Homeland Security in the US, $2 billion program. And we're now on the approved list and making our way progressively to federal and defense agencies through that. So cycles is one of the friction points. And the other is that in some of those situations, we come up against established known brand names. So very much it's the differentiation of our technology, our responsiveness, and I guess what some of our reference customers say that is helping us to be able to play on a playing field where you have some very recognized brand names in there.
Okay. And just to follow up on that with the quantum itself, do you feel like because quantum is so early, I mean, I'm constantly getting pitches on quantum plays, but it's a very early in the market. So do you find sort of the existing technologies, even though from your perspective, I'm sure you feel like they're dated and old, and you have this very new, game-changing technology. Do you feel like quantum is sort of a challenge to kind of convince people to look at the technologies and buy?
Really important point you make there, Mark. To some extent, yes, but the way we've actually looked to contend with that is to solve today's problems. So enterprise scale encryption is a problem today that most enterprises are dealing with. And if you talk to them about the key management problem, they say that is typically what is holding them back from being able to encrypt holistically. So not just piecemeal across the organization, but at enterprise scale. So we're solving that problem today, but the way we're doing it is introducing the quantum random number generation. Essentially, you get it almost for free as you implement our enterprise scale key management solution. But also we're building in all the hooks to be quantum safe as and when those organizations decide to make the transition towards technology like quantum key distribution. So the positioning is solving today's problems, but doing so in a way that enables you to be quantum safe into the future. So your investment is not something that you'll have to replace in the near term.
Thank you.
One clarifying point from my end, you mentioned you were getting into the edge space and IoT. I'm wondering how far along you are in that process, if it's just some initial prototypes or if you've engaged with some partners early to try and test out some ideas.
It is fairly early on in the IoT space for us. We have just recently received our first test chips around the random number generation. So on that side, we are very keen, in fact, to be exploring partnerships for go to market. However, on the enterprise key management side, what we've already seen is a few folks that are doing IoT style devices, particularly in the healthcare sector, interestingly enough, have been engaging with us to be able to uniquely identify those endpoint devices. So early in the piece, but we're starting to see interest grow quite rapidly and are very keen to look for partnerships in this space.
Yeah, thank you.
Thank you.
Any other questions from the judges?
A last question. Who is your most dangerous competition? Because you're in a space with a lot of legacy. I understand your technology is good, nice. When you lose, why do you lose?
Yeah. So when we lose, a couple of the reasons. One is that it could be that we're up against a well-entrenched existing player with strong relationships. Our focus very much, as you would have seen, is on large enterprise. And in some of those competitive situations, once or twice we have seen, or maybe 3 or 4 times, where the technology group within the organization has actually preferred our technology over other options that are available. However, because of those existing relationships at senior levels, we have lost out on that particular deal. And other times, Where we've lost is sometimes it's easier just to follow an upgrade path within incumbent rather than look at a technology refresh to go for companies like ours. But happily, in almost every case, once we've gotten to a POC, it has then followed through into a production deployment.
And how do your customers quantify the benefit?
There are probably about 3 dimensions on which they do that. So one is a recognition that we would, the cybersecurity they have would benefit from true random number generation. So a number of our customers selected our products just for the fact that we have this ultra high speed quantum random number generator. The second is to have sophisticated enterprise key management. So as opposed to having a database encrypted here, an application there, and some third application elsewhere, and really have a patchwork of encryption, which is very difficult to manage across the organization. Having an integrated key management solution has been one of the drivers. In fact, we took an investment from a US organization very well connected with the classified community there, and their CEO remarked that they had not seen innovation in the key management space for a decade, and that we're very pleased to see what innovation QLabs was bringing to the table. And the third is that what we've done is we've integrated some of these core capabilities into a very well-defined, robust enterprise scale, secure platform. So as opposed to having multiple appliances running in their stack, the third thing that customers really liked is this integrated single appliance approach.
All right, great. No more questions from the judges? Okay, thank you, Vikram from QLabs.
Thank you very much.
All right, let's give a minute to the judges to enter their scores, and while we invite the presenter from DOT Incorporation to step onto the stage and start sharing your screen.
Thank you. I'll wait your signal to start.
Yes, yes. And judges, give me a thumbs up when you're ready to go. I have 30 more seconds on my clock if anybody needs it. Okay, good to go. So next presenter is from DOT Incorporation, who makes assistive devices to eliminate the information gap for the disabled people. Eric, please start.
Thank you very much. Hello, everyone. I'm Eric, CEO of DOT. I studied in University of Washington, Seattle, major in social science and entrepreneurship. I'm also, I had 3 startups before, and this is my 4th startups. And I'm also 30 under 30 Asia Social Entrepreneurs Forbes Fellows. After I became Christian, when I studied in the US, I saw this Braille Bible book. It was so shocking to me because one tiny Bible book becomes 22 Braille Bible book after translation. Can you imagine what if we live in the world without the monitor? For 30 years, over 285 million visually impaired people needed the tactile monitor like this. But what available right now is just one simple one line of text available, Braille text available device with the cost over $30,000 to $5,000. And to achieve this full page tactile display, it's too expensive to achieve it. And there were so many fails, no one succeeded, like this EU-funded government project, Anagraph project. Finally, DOT made the 10 times smaller, lighter, and cheaper deep technologies. And with this, we created the DOT Pad. DOT Pad gives the full opportunity for accessing all graphic materials for blind people with the standard format of Braille text. And right now, DOT is the only one company can achieve this. So as you can see, this is the ultimate technology like Macintosh first came out that enables GUI for the first time with a much more affordable price. And not just the hardware, DOT Cloud is the most strongest AI engine to translate all text in 13 languages and tactile graphics onto the DOT Pad. This is the current worldwide method of teaching STEM education for blind students, very manual way. Because of our innovative technology, DOT is selected as an official technology supplier of the United States Department of Education from 2022 to 2026 to digitalize all the materials that's studying right now. Through our technology, now blind students and blind people can have more diverse job and diverse education. Every STEM education and coding, physics, all subjects are possible. Moreover, we are also collaborating with Apple that enables more blind people to access iOS system. And not just Apple, we're also collaborating with Microsoft that enables Windows Office on our .pad so that they can do more productive ways of work. Right now, we are scaling up so fast with the US government-approved technology. In 2021, we're going to be in the standard model in 5 countries. And in 2023, we're going to be in 30 countries standard model as assistive device. We are in huge market. It's $20 billion market. And we believe in 3 years, we can scale up in 30 countries, include G20 countries. This over $2 billion of value. We have 114 patents globally to innovate this. And we are the passionate team of 32 people from top universities around the world and global companies like Samsung, LG, Nokia, and ServiceMan with the over 20 years industry experiences. After .pad, what's next? We are in $2,000 billion smart city market, barrier-free IoT infrastructures with our core technology.
Now that we have developed that display, we are expanding access to the world of images, with it to the vision of barrier-free mobility. The first step we have taken towards guaranteeing mobility rights for all is launching .kiosk.
.kiosk?
We're collaborating with Samsung Kiosk team and already over 100 customers. We are enabling the generations with the disabilities. Thank you very much.
Great, thank you, Eric. Over to you, judges, for your questions.
Hi, this is Zach here. I mean, this looks pretty impactful. I'd just like to clarify where you're focusing either first or where's your area of expansion? Are you primarily B2C or do you see yourself as primarily B2B?
Well, right now we are focusing on B2G area and also B2B. Our first priority is secure the big contract with each government. So like what we did with the US Department of Education. Currently, we also secured a big contract with the South Korean government and also Japanese government. And after this, B2B contract is followed. So right now we are with the innovative technology, every government wants to provide accessible tools to make graphic available for every blind students and every blind employees. So we are providing like displays right now with the B2G contract first and also B2B contract.
Okay. And why did you start with your watch? Which I saw was your first product out there.
Well, that was our MVP product. Thank you for asking that. And also, watch was the first Braille smartwatch in the market. At the time, Apple Watch was like everywhere. So we also, made with our technology, we made the first wearable device for the blind people, and it was very successful. We've been featured in many, medias, and we've sold more than 10,000 units, but it was B2C, and it was very hard for us to focus on the B2C market as like hardware and software, both providers. So we pivoted to the B2G market and B2B sectors and more valuable market. And we believe this is the PAD market.
Got it. Thank you.
If I can jump in, first I'd like to echo and say that this is really looks like a very impactful idea, very, very impressive. The question is around the barriers to entry. I mean, you mentioned that you have lots of patents, but just looking at what you've shown in your presentation, it looks like something that consumer electronics companies perhaps could easily copy. Or I mean, let's say this is being adopted in the world. How do you protect your business?
Well, the first one is obviously, thank you for a great question. Obviously, it's the patent. And also, like I explained, we have, for 30 years, like MIT, Stanford, and many companies actually try to innovate this market, but we are the first one that actually succeeded to mass produce with the affordable price and also 10 times smaller and 10 times lighter size. So we have the most advanced technology, and we are keep improving right now also. So I think the speed from this advantage is the first one. And also, we are working with the global patent firm also. So I think securing patent is also very important to secure our technology. But right now we are also very fast in the market. We are already working with the U.S. government, already working with Samsung and Apple and Microsoft. And our goal is in 3 years we want to be in the standard technology around the market. So after that, I think all the standard and the UI will be us. So we would like to become a small Apple in this market.
Where do you produce these? Like, do you have like contract manufacturers? I mean, is it difficult to produce? Is it like, or the design?
Well, I think we got help from Samsung actually. We are working with one of the vendors from Samsung to manufacture this kind of technology. Of course, all the core technologies manufacturing is here in South Korea. We are doing by our own, and with our own engineers. But for the mass productions of the dot pad, we're collaborating with one of the vendors of the Samsung.
Eric, could you say a few words about your content? How you make sure there's enough content, as you say, in different language? Who is doing the content? How are you stimulating it?
Thank you for the great questions. Actually, like I show you on my slide, we have the AI engine right now that can translate all the text on the web and all the graphics on the webs. So basically, what we are focusing on right now is translating all the education materials for the U.S. government. So all the K-12 materials first, and then the university materials too. So right now we are in gathering the data and for the education sectors, and after this we're gonna expand this to the the vocation sectors. So we are working with Microsoft and Apple and Samsung right now. So as more people using our devices, more data will aggregated. With like Apple and Microsoft, we are working with few key software like PowerPoint, Excel, and Keynote, something like that. So we're gonna provide the key software to the customers, but also third-party developers can develop their app, their own app on our platforms. So it's like a Samsung and Apple's model. So.
And what is the quality of the translation? Have you generated a lot of content so far? And how will you grade the quality of the translation?
Well, we have right now the most accurate translator in the world. And that's why US government selected us as official partners. We are exclusive partners, not just, we're not one of them. We are exclusive partners. We competed with over 20 companies for this $30 million contract, and we won it. And we are the best technology provider right now in hardware and software. So I think, and U.S. government, traditionally they made the worldwide standard for this sector, and we think and we believe we're gonna be the next standard in this market, so that we can actually change every paper materials and one-line braille displays. It will be history, and we will be the future.
So Eric, I'd be very interested to know a little bit more about your prior startup experience, and also a little bit more about the team that is behind the company.
Well, thank you for the great question. Like I said, I had 3 startups. My last startup was called Wagon. I was a front-end developer and co-founder. It was an Uber for truck. So in 2014, there was many startups like Uber for something. So we were one of them. But like what I felt was I wanted to do meaningful things because I really want to change the world as a student entrepreneurs. And I found this problem when I visited the church after I saw Braille Bible. And after that, I follow my destiny actually. So I came back to South Korea and I created this company, Dot. And after that, we went a lot of competitions to pitch these ideas. And we actually won one of the Shark Tank in South Korea. It's called Pentagon. And after that, we were kind of famous in South Korea. So we could actually hire many engineers from Nokia and Samsung and LG. They want to participate with their shares. So, early members from Samsung, Nokia, and like LG, those great engineers, joined with visions, and also I gave them shares, so we could actually hire great engineers over experienced 20 years. And right now we are a global team, so we have our US team and also expanding our sales team right now.
But in terms of senior leadership beyond yourself, would there be any folks in your team that you would cite as being leaders of the business with you that are helping to drive that success beyond the basic engineering?
Well, it's kind of our secret sauce, but my father is actually very famous engineers in mechanical engineers in South Korea. He worked for Nokia and many great companies to transform technologies to China and many places. So, I could actually get very good network and also get my father's help at the very first time, because previously I had only software startup experiences. So this is my first hardware startup. So I could get a lot of help from him. But right now he's in our executive advisors, and he's helping our team with his people, with engineers. He has a lot of engineers fellows behind him. So it's kind of our secret sauce, but so that we could actually secure core technology very well.
Great. And one more question: as you contemplate actually turning some of these powerful relationships, like Department of Education here in the U.S., to business, I mean, what is the routes to actually generating money for the company? In other words, are you looking for California School Board to decide that this is going to become the device that gets used within the school system? Is it a government route still, or is the endorsement from the government a way that you have private buyers for your technology?
Well, Jack actually asked us about the watch. So we had the B2C product at first, but we're already in this market over 5 years. So we went a lot of the seminars and a lot of the event exhibitions. So we could actually generate the initial network from there. Every year we bring the newest technology and great technology to the market, and we could actually make great network through there. And like 2 years ago, we could actually show to the U.S. government our recent technology, our DotPad technology, and they were really fascinated. And what they said was, right now, it was early 2020. They said they have the new project from the U.S. government that they're gonna change, every materials for blind students. They're gonna change to the digital way, and they're looking for the technology. And this problem was for 30 years. Many people tried to solve it, and U.S. government actually want to solve it in actual level. So we applied that, and we competed over 1 year, and we could be selected as the official technology. And this is a great achievement, because U.S. education, Department of Education has most powerful power to the market. So basically, like every state education department follow their routes. So we got the big one right now. So in next year, we're gonna be in California, we're gonna be in New York, we're gonna be in everywhere in the US, also like Canada, like North America. So we think right now we are at the edge of the changing. We are at the edge of the big wave right now. we're going to be the history changer. I strongly believe that. And in 3 years, around G20 countries, our technology will be used with so many students. I can guarantee that.
Great, thank you.
Just Eric, just a question for me. So I'm trying to understand from a go-to-market approach. I understand it's B2B, B2G. Do you see yourself making and building the end consumer product when you sell into the B2B, or do you feel like the primary go-to-market strategy is going to be an OEM embedding your underlying core technologies into other solutions that are existing out there? And tagging on that with the team part of it is, if you are going to be doing an OEM and an embedding strategy, talk about your team, or at least your thinking around the team that you feel like you need to put together from a go-to-market perspective. It sounds like you have a lot of strength in your engineering, but I'm really curious how you're thinking about leading the charge around driving the go-to-market with respect to your bundling and OEMing strategy as you kind of, move the company forward.
Thank you for the great question. As you said, we have limited resources. So our strategy was focusing on the big one, focusing on the big contract as much as possible. That's why we focused on the U.S. government contract. And for our go-to-market strategies, we actually build end product. We were building product like Samsung or Apple, and we actually like Jack asked, we have an experience that provide the world first Braille smartwatch in the market, and that was sold in 20 countries worldwide. And also, like I said, we are working with Samsung for manufacturing so that we could actually have a premium manufacturing power in our company right now. So right now, unfortunately, there's not many companies can produce like this kind of things, our dot pad. So right now we already made a device, and we show it to the US government, and then they choose us. And right now what we are focusing on is mass productions. That's why we're raising right now to the South Korean investors and the worldwide investors right now. We're about to do the mass productions, and we already succeeded in mass productions before. So for us, it's not a big problem. And we already have a really strong team for that. So we are making end product, and our go-to-market strategy was focusing on the big contract. So followed by the U.S. government contract, we're focusing on the Japanese government contract, South Korean government contract, and the EU government contract. So we are with the U.S. government contract, we are showing to the other government education department that our technology and this deal, it actually kind of followed by that deal. So and also we are also lack of many sales force right now. That's why we are raising, and we are only 32 people. So with after this round, we're gonna increase our sales member over 30 people. So we are rapidly moving to the global market.
Okay, any other questions for Eric? Good, thank you,
Last
Eric.
Last question, Eric. Did you see over time the value of your company to be more on the AI, automatic translation software, or the hardware? How do you see the balance, at least from an R&D investment standpoint? Where, let's say 5 years down the road, where are you going to put the most R&D dollars?
Well, I think our core technology is, like I showed to you, our core technology is the display technology. So we're gonna keep making the more accurate and more density display technology, like tactile display technology. This is actually haptic technology. So we have our own lab, and we have most experienced engineers in South Korea. So this is the one part that we're gonna focus: display technology, haptic technology. And the second one is our software. We need to create the platform right now And platform is about to begin with the great collaboration with big companies and the US government. So we're going to focus on two things: display technology and platform, making platform little Apple, little Samsung in our product roadmap.
All right, great, judges. And thank you, Eric from DOT.
Thank you.
All right, a couple, maybe 30 seconds for the judges to finish scoring. And let me invite a presenter from Pixel to the stage. Pixel, do you want to get your, okay, great.
Hope everyone's able to see the screen.
Yep, we can see your screen.
Everyone, thanks for the time. I'm Aviz.
Hang on for a second. Hang on for a second. Judges, good to go?
Yes.
Yep.
Okay, great. Now turn it over to the presentation from Pixel, who's building the world's most advanced satellite constellation. You have the floor.
Thank you. Hey everyone, Aviz here. I am the founder and CEO at Pixel. We are a space technology company, but more specifically a space data company. So that involves two aspects, the space aspect and the data aspect. We build satellites that we ourselves deploy in space. And once the data comes down, we also build the tools and the infrastructure that enables any organization to take that data and convert it into an actionable insight that they can use in their day-to-day operations. So the journey of Pixel starts with a couple of experiences while still at college. So it was started by two co-founders while we were still studying in the final year of undergraduate studies here in India. But we had always loved space. But there were a couple of experiences that led to Pixel. The first one was being part of the student satellite team that was working with the Indian Space Agency directly. So that's where I learned what it actually takes to build a spacecraft that would work in the harsh confines of space. The second experience was being a founding team member and engineering lead at Hyperloop India. So when SpaceX came up with the competition, they said, we have a 1 mile long vacuum tube at our headquarters. You have to build a vehicle that could travel at really fast speeds, almost the speed of sound. And we were the only Asian team that was selected to manufacture this pod here. We took it to LA. We presented to Elon Musk and the rest of the team. And that was the steepest learning curve I'd had till then, learning, again, something that has not been built before and something that can move at really fast speeds in vacuum. But while we were in LA, they took us on a tour of the SpaceX factory, looking at the rocket engines being built, looking at the Falcon 9 rocket that had first landed back on Earth. That's when it crystallized in my mind that space is the space for me to be in. I'd rather not work anywhere else. So I came back and started working with existing sources of satellite data, started exploring what's happening in space technology, what can be done right now, where are the opportunities. But that's when we realized certain issues. When we looked at solving certain problems which only satellite imagery could help solve at that scale. For example, water pollution. Water pollution alone leads to a loss of $4 billion every year for the United States. Or if you're looking at agriculture, every year 40% of all grown crops are lost to pests. That's about $540 billion in lost revenues. There's no way for us to be able to reliably identify what pests are causing these issues. Or if you look at oil and gas leaks, every year there's about trillions of cubic feet of natural gas that's emitted that is not caught on time. Apart from the financial loss that it causes the companies, it also causes irreparable harm to the environment. So the problem essentially was that the existing satellites that were up there today, the data of which we were using to analyze and identify these issues, they were blind to these problems. We wanted something up there that could see these issues. And that's where the plan formulated. Here's what Pixel would do. We would build and deploy a better class of imaging satellites that would provide 50 times more information than any existing satellite that's up there. And that technology that would enable us to do that was called hyperspectral imaging. So this constellation of hyperspectral imaging satellites, once we deploy around the globe, would provide daily coverage on every place on Earth. So no matter geographically where you are, you would be able to see things that are changing on a 24-hour basis. What exactly does hyperspectral mean? On a very basic level, the information that you get down from space today is in either 3 channels or in 10 channels. Hyperspectral gives that to you in hundreds of channels, and that's the gap between providing 50 times more information. This is a real-world example of what that looks like. On the left is an image taken by today's satellites, and on the right is a hyperspectral image. Hyperspectral enables you to see that there's actually contamination in the lakes, which you could not have seen otherwise. And there are multiple industries where there were use cases, not just these. be it mining companies, be it natural gas companies, be it agricultural companies, urban planning governments. All of these required a better class of imaging where you would see these problems in the first place. Take, for example, this oil and gas field. There's a natural gas leakage that's occurred in that pipeline there, which you would not have been able to see otherwise. But the hyperspectral image on the right clearly enables you to see that there has been a leakage. So what exactly is it that we do? We build and deploy our satellites to space. We have partners that enable us to beam down this data to the ground, and then we upload it to the cloud, and we have a platform that anyone can come in and use to extract insights from that data. So it doesn't matter if it's just the imagery that people want, or if it's the tools and infrastructure or direct insights. Our platform enables them from a developer to a data scientist to a manager to take this data and convert it into what he actually wants to see. So we're moving essentially from what we can do today, which is identifying between healthy and unhealthy crops, to a 3D representation where you can see a lot more than is possible. So that enables us to do it for every farm every day. When we started, we were one of the 10 companies in the inaugural Techstar Starburst Space Accelerator, where we got to work with organizations like NASA Jet Propulsion Laboratory, which actually invented hyperspectral imaging. We worked with the largest Earth imaging company, Maxar, who we are continuing to work with today. The US Air Force was given us a letter of support for procuring this data. We have built out our camera that would enable us to do this, the hyperspectral camera that would enable us to see these things. And the satellite has also been manufactured, integrated, and tested all at the Indian Space Agency's testing facilities. And it's scheduled for a launch in October this year, with a second satellite that is currently being built that's also booked to launch in December on a SpaceX rocket. So 2 satellites that are going up this year, one which has already been built, the second one which is being built. Apart from the hardware itself, I was mentioning to you the platform where people can search for data, in a map-like format. They can analyze, they can create their models, and in a very easy to format, they can drag and drop these blocks and create a pipeline. It's as easy literally as them choosing what they want, dragging it into the lab space and connecting it into a workflow. They would not have to have any degree or any team that's specialized in doing this. The roadmap looks like this. 2 satellites that we are launching this year. We plan to launch 8 more next year, which will get us to a sustainable status. But the plan is to do about 36 plus 6 satellites by 2023. That would provide us that global coverage and enable us to cater to the customers that are there. There are others that are existing today which do not do hyperspectral, but there are also others that are trying to do hyperspectral. The thing that differentiates us is the quality of our data. When you look at what others are trying to do, our resolution is at least 6 times better. We have made our satellite much smaller than what others are doing. From a 300 kg satellite, we have brought it down to about 40 kgs, and that's important because the cost of the satellite depends on the weight, and the launch cost also depends on the weight. We have been able to manufacture this satellite in just under 6 months, and since we are manufacturing this in India, we have been able to do it at about 1/10 what it would have cost us to do with someone else or somewhere else. As I said, the company was started by 2 folks in college, but we knew early on that we needed to get folks with experience. So now we're a team of about 35 folks, with people coming in from the Indian Space Agency, people coming in from teams that have built lunar landers and rovers. But our chief science officer is someone who's worked on hyperspectral cameras for the US government, multiple patents in camera engineering, who's helped us get to the point where we are today. So essentially, along with the team itself, we have surrounded ourselves with investors and advisors who have been there and done that in the industry. Ryan Johnson that you see on the left, he was the CEO of his own Earth imaging company and a president at Planet Labs. He's an investor in us, and we work with him very closely to accelerate our business development efforts globally. Goddard was his right-hand technical person that built the technology for the constellations at those places. And Jordan is a co-founder at Relativity Space, a 5-year-old rocket company that has raised close to $1.3 billion in the past 5 years. A combination of startups and established companies are helping us move faster. Just summarizing, when we're able to deploy this constellation, we will be the world's first commercial hyperspectral constellation in the world. But the fact that we're doing hyperspectral means that we'll also be deploying the smartest Earth imaging constellation in the world. However, it just doesn't stop there. The same technology can be used to scout resources on the moon, Mars, and the asteroid belt later on in tandem with the space agencies like NASA or ESA. So that's about us. Thank you for the time. Happy to answer any questions that you might have.
Okay, thank you for the presentation. Judges, please jump in.
I can start this one. So I know Ryan, and I'm involved in the space cohort at the Creative Destruction Lab with Chris Hatfield. So I've been pretty involved in a bunch of space startups. I think what's interesting about, I guess the question I have for you is, in our space cohort in CDL, you know, the primary driver is startups doing analytics around Earth observation imagery. That's pretty much what space is today. It's about lunar modules and firing rocket ships in space as much as it is about analytics in this day and age. I'm curious sort of where you see your beginning and end in your market. There's a ton of startups out there utilizing data from Earth observation to be able to then do analytics. So there's companies out there like Descartes Labs that, you know, they specialize in deep analytics, AI, machine learning around capturing this data. Do you feel like you're going to kind of focus more on the bottom end of the pipeline and being able to access and acquire the data, and then on the pure hardcore analytics, you're going to push that out to companies like Descartes? Or do you feel like you're going to start playing in the same space as a Descartes and some of these other companies? How do you see that?
We see companies like Descartes or Orbital Insight or any of these analytics companies as our customers. So what we focus on is getting this data down in a high quality format and providing the tools and infrastructure through the platform. So whether it's a Descartes Labs team that has experience already that wants to come in and do some sort of advanced correction on the platform, or whether it's the end user like an agricultural company themselves, across the entire value chain, it depends on the customer how deep they want to go. So even companies including Descartes Labs would be customers of the platform. So we don't ourselves anticipate going and solving each and every use case in each and every industry. That would be left to these analytics companies that have come up in those industries.
Okay, great, thank you.
I have a question about the end of lifing of these satellites. What would be the life cycle, and have you considered their end of life to reduce space debris?
Yeah, so we already have the licenses that are required to send this satellite to space. One of the requirements for getting a license is that we have to prove with enough confidence that we can deorbit the satellite without leaving any debris up there, which we have been able to do. So the satellite has an active mechanism through which it deorbits itself in about 5 years and disintegrates without leaving any debris up there. The lifetime of the satellites is about 7 years. So once the operation is done, 5 years after that, it disintegrates in the atmosphere.
Got it. And you mentioned that you will be playing a little bit in the analytics space. So I'm curious how you're developing your ML models today, with what data, or if you're waiting until you get your own data source to train models.
Yeah, we are doing it through two sources. One is there have been some open source hyperspectral data sets through NASA that have been available, which we're using. But we also have a smaller version of the same camera that is going on the satellite that we can put on drones and on airplanes. So we have paying customers today through whom we are running these pilot projects already with this camera. That same data collection is what we're using to build on the algorithms. But there's also partnerships with Maxar that I mentioned. So the Worldview 3 satellite that we have exclusive access to some data for some areas that we're using to build our algorithms. So it's a combination of all these.
Got it. Thank you.
And when you launch, what would be the first application, or who are the first customer likely to use your data for which use case?
Sure. So we already have paying customers in the segments of urban monitoring. We have a customer in the agriculture space, and we have a customer in the oil and gas space. The good thing once we deploy the satellite is that once it's up there, we can use it for multiple use cases at the same time. So the plan is right now, the urban company, it's a smart city, super city project where we are the geospatial partners. The use case there is to be able to identify the different kinds of lands and water and the health status of the soil and the water. The use case on the agricultural company, it's a multinational, multi-billion-dollar agri company. The use case there is identifying between growths of different species of crops. And on the oil and gas sector, the use case is monitoring oil and gas pipelines for leakages. So these are the three that we will focus on once the satellites are up there, because we already conducted pilots with these customers, and the next step is scaling up.
And sorry, my ignorance, how often do you scan a specific piece of land? Is it every day? You know, with your orbital positioning, how often can you refresh the data on a specific geography or specific city?
So by September of 2022, with 8 satellites, we'll be able to do any place on Earth every day. So if I take an image of Los Angeles today, the next image of Los Angeles will be 24 hours later. And we're able to do that with 8 because we have capability of maneuvering the satellite in space. With 36, we'll be able to serve more customers, but the frequency is daily.
If I can jump in with 2 questions, please. One, some of the use cases that you described actually are being served by drones today, or there's an attempt to start serving them with drones. If you looked at the economics, how would that compare? Of course, not all of the use cases that you want to target, but like in agriculture, or if it's monitoring a specific line, gas or things like that. So that's one question. The second question is if you can share a bit about the experience of the team around satellites in general and satellite imagery, which is, by the end of the day, quite different from even hyperspectral imagery from a drone. And even training, is maybe difficult, right, if the source is not the same. So if you can share about that.
Yeah. Some of these use cases are definitely being done by drones, by our customers themselves. But the issue becomes that after a certain area, the dollar per acre figure becomes more costlier for a drone than it is for a satellite because of the areas that you're looking at. I'll take an example of a customer that we'll be working with. They are getting into a carbon monitoring program, a carbon sequestration, carbon credits based thing. And that's a use case that cannot be done with any data that's up there in space. But at the same time, they have use cases for crop health detection. They have use cases for soil health detection. Only hyperspectral imagery can do all those at the same time. You just need to take one image, and they have those 3 use cases, which means that the dollar per acre figure that comes out to them per use case makes an economic sense for them, which won't be the case if you're just serving one use case. And that applies for multiple customers along the way as well. So the most ardent customers that are waiting for us to provide the data are the ones that have already used it from drones and airplanes. They know the value of this data, and they want to use it for large scales, statewide, nationwide. Answering the second question on the team itself, we have, as I mentioned, on the camera side, Dr. Yafuso, but on the satellite and satellite imaging side, we have scientists from the Indian Space Research Organization. Some of them have worked for 20 to 25 years, have led their own Earth imaging satellite programs here. They have built, deployed, operated those satellites, as well as we have some younger folks from the same agency who've been there about 5 to 6 years. So in a team of about 35 folks that we have, I would say 7 to 10 folks have come in from a satellite building, satellite manufacturing, and satellite operating background, previously from the agency.
All right.
Well, last question. I'm not so sure I understand very well your competitive advantage, at least for some application versus drones or planes.
So I'll take an example of Bayer Crop Science. They've been doing drone hyperspectral testing for ages, but the amount of land that they need monitored is in millions of acres, millions of square kilometers. And they simply can't do that with drones because one, the logistical cost and the logistics themselves become a nightmare. Secondly, you can't cover that much area with multiple drones. You don't have uniformity. So as I was mentioning, be it in Europe, be it in North America, be it in Asia, the customers that are waiting for hyperspectral data from space are the ones that have been using airplanes and drones. There will be certain use cases for airplanes and drones on a smaller scale. Like if someone owns a very small sized farm, then drones make sense for him. That won't be our customer. The customers for us are ones that look at these lands in a county scale or a state scale or a national scale.
So do you see some customer doing some data fusion, taking the data from your satellite, combining with some specific flight of drones or planes, or they will be pure satellite?
No, like what you said exactly. So the names that I've mentioned, they use satellite imagery as the first level of warning. So once they identify that there's a problem in a certain area, that's where they focus drone collection or airplane collection on. So it's a step 1, step 2 process where most of our customers will use satellite imagery for large scale analysis. Once they have identified a smaller area, that's where they deploy drones or people or IoT sensors for them to be able to go and identify the problem.
Great.
Thank you.
Great, thank you, our presenter from Pixel. Now, our last presentation today, Multi-NanoSense, a cutting-edge gas sensing solutions platform. Please take the stage, start sharing your screen.
Hello, am I audible?
I don't see your screen share yet.
Yeah, just a moment. I'm pulling it up.
Okay, good to go.
I'll just give me 5 seconds. Perfect.
Okay, please start when you're ready.
Very good day to everyone tuned in. I am Shashank Kumar. I am the co-founder and director of Multi Nanosense Technologies, and we are enabling the future of gas sensing. I will first talk about our solution and how it can help hundreds of deep impact use cases, translating into a large market opportunity. Then I will describe our execution plan and what we are looking for. We are building an enabling key to interpret crucial gases around us. A solution which is affordable, reliable, versatile, very small, and connected. It is predicted that the total number of smart edge devices shall be 50 billion by the end of 2025, and we believe that the gas sensors will be a crucial part of it. They will enable connected intelligence, before demand prediction, diagnostics, and well being of the planet, cutting across all walks of life. To blend into everyday usage, it is only possible if gas sensors get from where they are to a miniaturized, affordable, yet powerful sensing system like accelerometers and gyroscopes of today. With this goal in mind, Multi Nanosense has developed a platform OmniGas sensor which can simultaneously measure multiple gases and gas flow in a single MEMS die. This solution addresses 10 most critical shortcomings faced by traditional sensors and will be 50. Pardon?
Go ahead, please continue.
And will be 50 to 100 times cheaper and 1,000 to 2,000 times smaller than traditional sensors. On the performance aspect, our sensors respond in microseconds and can potentially analyze all kinds of gases selectively, qualitatively, and quantitatively from parts per billion level to 100% purity. These sensors will be suitable for plug-and-play integration with standardized digital outputs. Most importantly, we are addressing the main issues of cost, performance, and size, which have historically restricted widespread deployment of gas sensors in daily life. The technology was invented at the University of Cambridge, and Multi Nanosense has an exclusive worldwide license to commercialize it. The inventor is also a co-founder at Multi Nanosense, and substantial know-how has been generated internally thereafter. Patents have been granted in USA and China, and nationals are under various stages of evaluation in the European Union, India, and Hong Kong. With the most important issues at rest, our technology can enable hundreds of applications across all walks of life. We have focused our attention on smart homes, smart vehicles, smart equipment, Industry 5.0, smart devices, and healthcare. Our goal is affordability with capability. The central theme of compelling benefits delivered to users is reliable intelligence at the right time for crucial decisions which save or improve life, optimize assets and processes, protect the environment, and generate long-term economic and social value. I can address each market segment and use case of interest in depth during the Q&A session. Our mission is to leave a sustainable positive impact on the world, which is reflected in the technology we are building. Interpreting and digitalizing information from gases around us can enable breakthrough in adjacent fields like biomedicine, agriculture, and food security. Breaking the cost barrier ensures equal social and economic access. The summation of individual efficiency improvement across the globe will significantly reduce carbon footprint, and awareness shall bring behavioral changes towards environment conservation. Applications we are working on, like pay-as-you-use LPG, enables financial access and safety to rural poor families that earn less than $200 per month. There are about 100 million such families in India. Smart air conditioning and power saving shall cut down carbon footprint and power demand through efficiency maximization, while creating awareness about indoor air quality to prompt responsible behavior. Sensors protecting passengers from lithium-ion battery or hydrogen explosion in electric vehicles and hydrogen vehicles shall play an important role in shifting to green automobiles. Each application has its own positive impact, which makes it very important that multi-nanosense succeeds in its mission. Based on the number of sensors we can sell at appropriate price points, we estimate that the market opportunity is $13 billion for our initial use cases and going up to $83 billion in the 7th year at full technology maturity. Additional use cases each year bump up the market opportunity exponentially. We intend to grow in an assured manner, creating credibility, impact, and action along the way. We plan to tackle applications with more demanding capabilities in a progressive manner. We shall ensure sustainability in the development process and also de-risk the company. The potential of our technology has been validated by world-leading corporations who are at the cutting edge of their domains. Strategic collaborations have also commenced with few of them and other OEMs who have appreciated the value proposition and proof of concepts. I will now talk about our execution plan. We shall grow our technology platform in steps, opening up new use cases at each step, starting from sensing all kinds of binary mixtures and greenhouse gases, then moving on to analysis of any ternary mixture in a pocket gas chromatograph concept with the ability to sense trace levels. Third and fourth stage are towards hardware standardization for a one-shoe-fits-all solution and miniaturization to NEM scale. This plan gives us an assurance in direction, leverages adjacent technology growth and cost reduction in MEMS and packaging activities, and ensures that we are not too early to the market. Our sensors form a component of a host product or is the heart of a smart device, lending gas interpretation intelligence to the product. We are focusing on B2B and B2B2C segments for OEM integration. Our philosophy, which has worked thus far very successfully, is to innovate and then validate the concept to build demand ground up. After successful demand validation, we build the POC for demonstration, and after getting user approvals, we move into the integration phase with purchase orders. Out of the 31 use cases we have planned, we have commenced development of applications in 9 use cases with 10 industry leaders after POC success. 4 use cases have been validated at concept stage with 4 large B2B customers. Lower down the funnel, ideation discussion is in progress for 10 use cases. Lead time from concept discussion to actual POC success is anywhere between 12 to 15 months. Hence, we have commenced discussions already in time well with the technology rollout. Our revenue model is fairly straightforward for the first 2 to 3 years, where we shall establish a critical mass of sensors in the market. Thereafter, we shall build on the intelligence and information services after market credibility and scale is achieved. Licensing of developed technology piece is also an option we have on the table for reaching the benefits of our technology faster and further. Let's look at our competition. Gas sensing is not new to the world and has existed for decades. However, the traditional approaches have been restricted to the industry and labs only and have not come out into daily life. Primary reasons are limitations in the sensing abilities and very high cost and complexity for high volume consumer applications. To address this challenge, companies like Bosch and Sensirion have come out with MEMS sensors, which have translated the metal oxide sensing principle onto the MEMS platform. However, they have similar sensing issues as the traditional tech and are restricted to particulate matter, total VOCs, and equivalent CO2 sensing. Unlike others, we are not restricted to one principle or a set of gases. We bring in a complete change in basic approach through first principles filtering and smart algorithms. The range of applications, selectivity, and accuracy, and other parameters of high performance are unique to our solutions. Our journey so far. We started our business in April 2018 and bootstrapped the initial period with about $95,000 and rolled out our solid state electrochemical sensors for hydrogen sensing through various POCs and demonstrations. We targeted niche customers and most complicated applications to distinguish ourselves. By March 2020, we had 12 paying B2B industry-leading customers giving us trial purchase orders. We raised a bridge fund of about $500,000 and did $65,000 in revenue. Then COVID hit us very badly and the economy started reviving only by January 21. Meanwhile, we worked on our use cases and market outreach. We won several competitions, out of which we were awarded most out-of-the-box solution by Applied Materials, with whom we are at an advanced discussion for custom solution creation. Business flow has been much better in 21, and coming to the present day, we have over 30 paying B2B customers with $142,000 in revenue and confirmed purchase orders from very niche customers. We have 10 customers who have the need and budget to start buying our sensors as soon as we can roll them out. We have also established strong collaboration with IIT Bombay and University of Cambridge for core technology development, 4-inch wafer proto fabrication, and high quality resources. We have built deep capabilities in gas calibration, sensor design, and electronics design. Our scale-up plan consists of one-time non-recurring costs for setting up the manufacturing recipe and process steps for every level of technology development. Thereafter, scaling up is more of an OpEx rather than a CapEx, and virtually sky is the limit. We are now actively speaking with foundries to put in place our manufacturing capacity with in a fabless manner with a low to medium scale foundry, which also offer design and validation services. We need to do this swiftly as we have customers waiting with a whetted appetite. We will transition to a large scale foundry once the demand crosses 20 million sensors per project per year. At the low to medium scale foundry, our product cost would be under $2 to $3, and at the large scale foundry, under $1 each. Other manufacturing activities would include multi-chip packaging in a system, assembly and testing by OSAT companies, sample gas calibration setups, and ERP-based global fulfillment for just-in-time contracts with OEMs. Since I'm running out of time, I will now quickly talk about our team. We have a strong cross-functional team and age-diverse core team comprising of 2 inventors of the sensor technologies we are applying and hardcore finance and business people. Professor Vasant Kumar is the head of materials chemistry at University of Cambridge and more than 20 patents to his credit. Apart from sensors, his work in sustainability, lead recycling, and battery technology is highly acclaimed. Mr. Ashok Kumar invented the solid-state sensor technology in India under very testing conditions and a shoestring budget. Our team has done the heavy lifting, and we are looking to expand our tech and marketing teams for high-tech development and the global reach. We also have a very strong advisory board as well as active investors who are based out of multiple continents, India, Europe, and the USA. What we are looking for in very 3 crisp words, we are looking for investment, we are looking for strategic collaboration, and we are looking for acceleration in our growth through strategic tie-ups. Thank you for patient listening. I know it's been slightly long, but I hope I have been able to cover most of the aspects of the business. Thank you.
Thank you, Shashank. Over to you, judges.
I'll jump in then. So this looks very impressive. You can sense everything, every gas, everything. So the question is, if you could briefly just share with us, what's the fundamental technology? I mean, how does the MEMS device sense things, and what's the level of maturity? Are we talking about something that you've already proven on multiple gases or on one gas? Thank you.
Just a second. I just have a little bit of water. My throat is dry.
Which right now is 3 centimeter by 3 by 3.
So the base technology is thermal conductivity. And essentially what we are looking at here is the core innovative aspect of the patent as well. Is this negates the convective effect of gas flow. So essentially our sensor is flow invariant and does not matter whatever is the flow. And since thermal diffusivity is a unique fingerprint for every gas, at the initial stages, we can look at known binary background mixtures for any kind of gas, wherever the thermal diffusivity is even slightly different from each other for the two gases that we are looking at. On top of that, the technology also has the ability of rapid thermal cycling of the heaters that are embedded into the silicon. And this makes it capable to reach up to 800 degrees centigrade of temperature, wherein the heater with a high emissivity surface layer is capable of emitting an IR. So essentially, the gas that flows on top of the sensing element uh, absorbs the IR, and basis the IR absorption, the greenhouse gases turn into cooling gases. So in those situations, our selectivity to greenhouse gases at the first stage of development is extremely high and capable of distinguishing and even quantitatively and qualitatively analyzing, depending upon the response to the amount of heat that those gases take away from the sensors. Essentially, what we are doing is we are measuring either the power, we are measuring either the current that is supplied to the heaters, and the gases, depending upon their thermal diffusivities, they take away the heat from the sensors. And depending on how much power is required, depending on how much current is required to keep it at the same temperature level, that is how we understand as to what this is. And then the software algorithms come into place, wherein we know and we've tested out, that is the entire facility we built out to calibrate and test it. I mean, we have almost about 25 gas mixtures that we have tested out these sensors with various concentrations, and each of them have a very unique, distinct response in the actual outputs that we are measuring. And those are very repeatable, very accurate, and I mean, the entire, either it is a math block or it is like a lookup table wherein you can get to the concentration of the gas. This is the first level. The second level activity comes in where we start putting in other chemical, other physical, other chemoresistive kind of technologies, other electrochemical kind of technologies onto the same platform, wherein we are on first principles basis, we are looking at the same gas stream with 3 or 4 different kinds of principles. Essentially, what happens is a family of gases which will have a similar response to, say, a catalytic combustion, or say a metal oxide based, tin oxide based sensor. The thermal conductivity would be distinctly different for those two gases, which would have a similar response in, say, an A principle, which would be distinctly different from B. As soon as we add another C principle, the further filtering down makes the sensor extremely selective to a particular gas, and the responses of all those principles put together and crunched through the algorithm, that gives us a very accurate quantitative result of what target gas we are looking at that point in time. And all of this happens in microseconds. So essentially, to the human eye, it is almost real-time sensing, and this thermal cycling can happen within microseconds. And we could be looking at simultaneous number of target gases within the blink of an eye.
Great, thank you. Any other questions for Shashank? Okay, good. Thank you so much for your presentation.
Did I bore all of you?
No, I think it was really comprehensive. I think they've got it. Thank you so much.
Thank you. Thank you.
Okay. Could you take down your screen share? Great. Well, I want to give a big thanks to the judges, Eric Batois, Dede Goldschmidt, Richard Irving, Zach Lashik, and Mark Cunningham. And huge congratulations to all the presenters today. We're really impressed, and I'm just so excited about your innovations. Just want a quick reminder that everybody's invited to attend the Extreme Tech Challenge 2021 Global Finals presented by TechCrunch on July 22nd. So this is the finale event. It is open and free, and also all virtual for everybody to attend. So make sure you join to watch the top contenders pitch, as well as stay for the virtual networking. And this wraps up the public pitch session of the Extreme Tech Challenge. Enabling Tech category final. I want to thank everybody from joining today, especially those who are staying up late or waking up early in your time zone. Make sure you follow us on social media to get the latest news and updates from XTC. So with that, I wish you a good rest of your day. Thank you.
Thank you.
Thank you. And judges, please look to your email for the deliberation link, and I'll see you there.
Thank you.
Thanks, everyone.
Thank you very much.